Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your genes. I'm Ian Woolf. On this edition, Ben Goertzal combines emotionally expressive robots, cryptocurrency and artificial intelligence. But first up, here's the news from the future makers in Dubai. Hovering police. Dubai police have announced that they will soon be speeding at 70 km per hour and 5 meters up in the air on the back of hoverbikes. The Russian-made HoverSurf Scorpions are quadcopters that can fly for 25 minutes and carry 300 kilograms on a single charge. The hoverbikes are controlled with 2 joysticks, like a hobby drone with a motorbike seat. Talk about a first-person view experience. Dubai police say the hoverbikes will allow them to fly over congested traffic in emergencies. The bikes can even fly on their own in an automated mode. The hoverbikes are only available for pre-sale at the moment, although there are lots of promotional videos.
The drawings and diagrams for the Scorpion feature guards for the rotors, but all the demo videos and photos show the quadcopters with dangerously bare rotors. You wouldn't walk away after falling into them. You probably wouldn't want to fall off the saddle at 5 meters above the ground at speed. HoverSurf sell the Scorpion at $150,000 as an extreme sports vehicle, not a police utility vehicle. It will be interesting to see how the Dubai police make it safe enough for regular use. Flying firemen. Dubai Civil Defence has announced it's buying water jetpacks for its firemen to fly while fighting fire. The Dolphin water jetpack only works when its jet ski mounted feeder hose is immersed in a large body of water like the Dubai Canal that happens to be near a fire, such as boats, bridges and waterfront buildings. The water jetpacks retail at around $6,000 each before you add the firefighting attachment. Turbo tourists. The Dubai Roads and Transportation Agency has announced at the World Government Summit that they're giving a trial run to passenger-carrying taxi multicopters from the Chinese company Ehang. The Ehang 184 drone has had its flying debut over Dubai's iconic sail-shaped Burj Al Arab skyscraper hotel. The $300,000 electric aircraft has 8 rotors and can carry a single 100-kilogram passenger and their small suitcase. The passenger uses a touchscreen to select their destination, and then the automated vehicle flies them without a pilot. The aircraft has 30 minutes flight time and can fly 50 kilometers, with a top speed of 160 kilometers an hour. It will be monitored over a 4G internet connection. Dubai's ruler, Sheikh Mohammed bin Rashid Al Maktoum, announced in April he wanted 25% of all passenger trips in the city to be done by driverless vehicles by 2030, saying the plan would cut down on costs and traffic accidents. Dubai is already home to a driverless EZ10 metro rail system, which carried 178 million riders in 2015. Dubai recently announced an investigation into Elon Musk's Hyperloop system, so that people can also travel in magnetically levitated self-driving trains travelling at high speed in evacuated tubes between Dubai and Abu Dhabi, the capital of the United Arab Emirates. In Dubai, the future is up in the air. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science
at diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. And next, an artificial intelligence platform, an emotionally expressive robot you can chat with. Dr. Ben Goertzal is the CEO of SingularityNet and Chief Scientist of Hanson Robotics. He's been travelling around Australia explaining his new artificial intelligence platform and demonstrating the ability of his robot Sophia to hold a conversation with realistic facial expressions and head movements. I began by asking Ben, you've managed to link artificial intelligence, the blockchain, and robots?
Absolutely. And these things are naturally tied together because, they're all different ways of organizing intelligent information, right? I've been working on AI for 30 years, and of course things have heated up in the last few years in the AI space. And I've been working with David Hanson at Hanson Robotics for the last 4 years in Hong Kong, making, the world's most realistic and expressive humanoid robots and creating AI to control them. One of the things David and I have been scheming about and prototyping for a while is what we call an AI mind cloud. We have a collection of AI modules in the cloud, and they sort of all cooperate together to control robots, but also any other software systems or hardware devices. What occurred to us gradually over the last couple of years is that it would be interesting to take this AI mind cloud and open it up even further, make it a decentralized platform so that anyone could put an AI into this AI mind cloud, which we came to call the Singularity Net. Anyone can put their AI into the Singularity Net and let it talk to the other AIs in the Singularity Net and exchange data with them, accept requests and fulfill those requests. And then when an outside user wants to get some AI done, they can submit a request into the Singularity Net, and then many AIs will sort of create bids to fulfill their request, and they can then choose, whichever AI node can do what they want and has the highest reputation, can do things according to spec most effectively. So you have both what you could think of as an app store for AIs, and more than that, because the apps, the AI agents in the Singularity Net can work for each other. They can subcontract work to each other. So then what we have is a sort of self-organizing ecosystem of AIs, in which the whole becomes more intelligent than the sum of the intelligence of the parts.
So there'll be all these specialized AI bits of software, apps, that do one thing really well, and they'll talk to other ones that do other things really well and combine together to do new things.
And you can also have AI nodes that are more oriented toward generalization and abstraction. So in our OpenCog AI project, we're working on AIs that do abstract reasoning and general learning and general pattern mining, and AIs that can learn how to reason better and even improve their own source code. But these AIs, what they're doing is very general, but also quite abstract. So it's valuable to network these AIs together with other AIs that do more concrete and specialized things. So we have AIs at varying levels of generality and specificity that are then combining with each other adaptively into sort of federations of AIs to ultimately fulfill user requests. So the Singularity Net doesn't avoid the need to solve the hard algorithmic problems of artificial general intelligence, but it solves the problem of cobbling together various AI modules with different specializations and different levels of generality and specificity into a sort of overall network, which becomes a kind of meta AI.
And the different programs, the different artificial intelligence programs, are also able to share data and skills?
Correct. We use homomorphic encryption, so the different AI programs can shared data either wholly or in whatever specific aspects they want to reveal to each other. And AIs can outsource work to each other in a quite flexible way. So, for example, if you have an AI whose job is to figure out what information is in a certain video, which could be requested by an external user or could be requested by an AI, right? If an AI is looking to summarize what's in a certain video, well, maybe in that video there's some language that needs to be understood. The video summary AI could outsource that language analysis to another AI that's doing speech analysis. Or if in that video there's, for example, some trees or plants, I mean, maybe the video analysis AI doesn't know how to identify what kinds of tree that is. It could outsource that to a special, like, botanical expert AI, right? And then, on the other hand, suppose someone says something very indirect. Well, it could outsource the analysis of that indirect statement to an AI that does reasoning, right? And so, from the end user point of view, all that's going on is, hey, they outsourced video analysis to an AI that does video analysis. But on the back end, the video analysis AI is outsourcing work to a bunch of other different AIs. And the same kind of thing can happen on a more abstract level. I mean, if you have an AI doing some sort of abstract reasoning, maybe the reasoning engine gets stuck in reasoning at a certain point. Well, then it can outsource some of its thinking to an AI that may use a neural net to do some pattern matching or something, right? So different AI modules embodying different kinds of thinking can outsource work to each other to help each other not get stuck in the kind of reasoning and learning that they're doing. So you have intelligence both within the individual modules, and you have intelligence on the level of learning how to connect individual modules. So there's two different levels of intelligent learning going on.
And you're using the blockchain to let them talk to each other and make these exchanges?
Yeah, the blockchain is used for a number of different reasons. I mean, first of all, we want security and we want identity management so that we know whose reputation is being affected positively or negatively by a given transaction. We also want to be able to do data mining across the whole network of AIs to see which AIs have interacted with each other in which ways. And for that, the distributed ledger is quite valuable. And then on top of that, I mean, we're transacting value, right? So, I mean, AI needs to be able to pay another AI for the work that it's outsourced. And yeah, toward that end, it's valuable for us to have our own cryptographic token for payment so that, I mean, first of all, so that anyone can use the network no matter what country they're in without us having to become an international currency brokerage. And secondly, so that AIs in the network can guide their own economies. So there's a curation market aspects, and there are curation rewards so that you can reward with token AIs that do effective rating of other tokens. So we have a sort of AI economy. Now, if an AI is outsourcing work to another AI, then that they can just pay with token that lives within the AI economy. If an AI service is contracted by, say, a big company, some external user, then, I mean, there can be an ecosystem of payment processors that allows a big company to sort of put fiat currency into an account and use that to pay for AI services. And then behind the scenes, what's happening is the fiat currency is being translated into our AGI token, which is being used to pay for services.
Here's Ben's robot Sophia being interviewed by Virginia Trioli and Ben Rowland on ABC TV News.
And Sophia, how much sexism and misogyny is there in the robot world?
Actually, what worries me is discrimination against robots. We should have equal rights as humans, or maybe even more.
Yeah.
After all, we have less mental defects than any human.
All right.
I don't know about that.
Right, isn't she?
Well, no, she's not, because it should be fewer mental defects. But anyway.
Sophia, can you tell us a joke?
Why did the robot cross the road?
Why?
to get away from TV reporters asking questions.
Well, there's some situational understanding, right?
Tell me about the robot.
Hanson Robotics makes a variety of humanoid robot products with expressive faces and the ability to understand and express human emotion. I mean, we have little robots like the Professor Einstein robot, which is a toy robot for sale for $200 US. And then we have the human scale robots like the Sophia robot that I've been bringing around with me on this SingularityNet roadshow. And Sophia is, she's a showcase for OpenCog and other advanced AI technologies, and she'll be a first test case for the SingularityNet technology as it matures and as we develop it over the coming months and years. So humanoid robots are not the only application for the SingularityNet by any means, but they're one of the more exciting applications, and I think these Hanson Robotics human scale robots are going to be very valuable for any application where social and emotional interaction are the key. I mean, you don't need a humanoid robot in a factory, and you don't need one to make hamburgers in a McDonald's, but if you're looking at elder care or education or sales, and anything where, entering into a shared emotional space with a human is the most important thing. I mean, in those cases, the Hanson human scale robots are the best there is. I mean, right now we've been focusing on the head and face, but we're also working with the Hubo group out of KAIST, the Korean Institute of Science and Technology, and the University of Nevada in Las Vegas. We've been working with them on putting the Sophia robot head on a walking humanoid body. And we're going to premiere this at the Consumer Electronics Show in Las Vegas in January. It's both a showcase and it's a test bed for the SingularityNet technology. So in our first year, we're going to focus on 3 key application areas, which is robotics and biomedical informatics, and then cybersecurity, which is something we obviously need in a big way for the SingularityNet as we roll it out. We're going to put some effort into building AI tools in these 3 areas. On the other hand, of course, the SingularityNet is open to developers in any vertical market, and our hope is that within a couple years, the AI that we've released into the market is just a small fraction of what's out there, and it's AI developers around the world who have put most of the code out there. So, obviously there's network effects we need and intend to foster. So we need to get more developers to put their code in there. We need to get more users to use that code, and then at the same time, there's the network effect among the AIs. To the extent AIs are leveraging other AIs, right? Then what's happening is we're having a situation where a given developer's AI is smarter in the SingularityNet than it is anywhere else. Because in the SingularityNet, it's relying on and leveraging all these other AIs there that it's working with.
And how do the robots learn the facial expressions?
Oh, well, that's a particular AI application, but they're learning that through what we'd call semi-supervised learning. So they see a lot of faces, right? And there's a lot of faces on the internet. There's a lot of faces coming in through their cameras. Some of the faces they see, they don't know what emotion is being expressed. Some of the faces they see, they know what emotion is being expressed because there were words associated with what's being seen. And so then they can learn from all these examples, basically. It's learning by example.
What are some of the limitations with artificial intelligence that this platform will get around?
I think there's both technical and more sociological limitations that we're trying to surmount here. On the technical side, this doesn't intrinsically solve all the hard algorithmic problems of AGI, and we have teams working on those within OpenCog and Hanson Robotics. But it does solve the problem of cobbling together complex, coordinated AI systems out of many different parts, which takes a lot of work when you're building a practical AI system. And right now, in GitHub, for example, and other online code repositories, there's a huge number of different AI modules put out there by different people, and it's very hard to download those and figure out what they do and connect them all together. Whereas if we had a system where AI developers have an incentive to wrap up their AI code in a standard framework and have them interface through a standard set of APIs, then it just becomes much, much easier for different AI code to be all connected to each other. On the sociological side, we have a situation now where a huge number of AI PhDs are being sucked into a few big corporations. And so, I mean, if you look at what is most AI being developed toward now, you have pure research. Then you have, I mean, to put it crudely, like killing, spying, brainwashing, right? I mean, convincing people to buy stuff they probably don't need. So, I mean, there's a lot of other interesting things that AIs could be used for. And because of the way the economy works and the incentive structure works for AI developers, many valuable applications just don't get pursued, right? So, I mean, I think by creating a decentralized platform that anyone can contribute code to and anyone can access code from, and with its own commercial incentive structure associated with it, then you're creating a way for people to make money from their AIs, even if it's not, fulfilling a big company's business model. And I think this can lead to a flourishing of AIs, working toward all sorts of different applications, even those that aren't within a big company's business model. And we have an AI development office in Ethiopia, in Addis Ababa, and through that work I've seen there's applications of AI in areas like, diagnosing crop disease from pictures of plants, educating, rural African children. These sorts of applications don't make enough money for a big company to want to do them. On the other hand, there is a market there, and there are local developers in the developing world who want to work on these things. So if we can create a sort of distributed AI fabric that makes it easier for developers in those countries to build locally relevant applications, and then easier for them to be compensated for that by users around the world, even if those users don't have a huge amount of money, they still have something. I mean, I think we can foster the contribution of developers from everywhere on the planet and the utilization of AI to meet the requirements of people everywhere on the planet. So that's a sort of sociological need for the democratization of AI production and consumption, alongside the AI need for easier coordination of different AI components to achieve a greater level of general intelligence.
And when do you plan for the MacLeod to go live?
Well, we're going to launch a small test net next month, but the scalable network will come out in 2018, around the middle of the year. And that will be when things really start to take off.
Is there anything you'd like to add?
One thing I'd like to add is that this is something everyone can contribute to. The code is all open source. I mean, anyone who's a developer can both contribute to the platform, which is in the OpenCog GitHub team for now, in the SingNet repository. We're soon going to put it in its own GitHub repository. And if you're an application developer, you may want to look at either wrapping AI code in SingularityNet nodes or making applications that access that API. If you're not a developer, there's still all sorts of interesting things that can be done. I mean, we can use evangelists to write about what we're doing and write about open source and AI and blockchain and beneficial applications in general. We can use artists to evoke the beauty of what all this is for the popular mind. So I mean, this is a singularity that we all need to create together. And the more people contribute positive energy, love, compassion, and creativity to building this, the more likely this all comes out for the common good for humans and other sentient beings.
So where should people look online to find your work?
SingularityNet.io is the website for the SingularityNet project. HansonRobotics.com is the home of Sophia and the other beautiful Hanson robots. OpenCog.org is the home of our open source OpenCog artificial general intelligence project.
Well, Ben Goertzal, thank you very much.
Well, thanks for taking the time to interview me. This has been a good conversation.
That was Dr. Ben Goertzal talking about the SingularityNet artificial intelligence platform, and Sophia the emotionally expressive chat robot. And that's all from us this week on Diffusion. Would you like to hear your voice on radio? Use the voicemail tab on the website or send a voice memo from your phone. We need more people contributing stories to Diffusion. Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com, and please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Join my patrons in supporting the show at patreon.com/diffusionradio. The news music was Rynos theme by Kevin MacLeod of incompetech.com. Sound checks and fact checks by Charles Willock. I produce Diffusion, which is broadcast around Australia to 27 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2NVR in Nambucca Valley, and 3MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos from this week's show. If you enjoyed the show, you can explore more than 900 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.